Oh yeah, yeah. And things change yearly, it feels like. All right, so there we go. So in 9.4, I would have to argue that this is probably the hardest part of this chapter because it's all word problems. But most of the time, they give you the formula. So all it is you plugging in the numbers into the variables you do know and then solving for the variables you don't know. So for instance, the first question we're going to go over today is talking about IPR or IPRT, which is known for simple interest. So I'll go ahead and give you the formula. So simple interest, which is I equals PRT. I remember it as IPERT, but this is your first formula. And then they give you the formula, but the thing, and I think they even tell you what each letter is on the homework. So you just got to make sure you plug it in correctly. So like I represents your interest. Your P is going to represent your principal, which is your starting amount. You think of this like a savings account or something like that. You put $1,000 in, how much money you getting off of it, or maybe you have uh, you know a mortgage or something like that. So you have interest and principal that's tacked on. So this formula has helped to calculate both. That and that's why it changes each month too. That's why you pay your bill doesn't change, but you end up paying more principal each month than you do interest because you're paying the interest that's being tacked on is becoming less and less because you're paying a little bit more on the principal. So that's kind of what these formulas kind of help you with. So again, principal is just a starting amount. Your R represents your rate of the interest. So if you got a mortgage of like 6% or 6.5% or whatever you're locked in right now, that's what that represents. And then T just represents time. And typically this is in years. So how long is this going on for? 5, 10, 15, 30 years or whatever it is. And so from there, then they're going to give you some information. So the information on this first example, it says you get a loan for 2,000. So here's your loan amount, $2,000 for 60 days. So your time here is 60 days. Hmm, sorry. At an annual interest rate of 6%. So it gives you your rate is 6%. And it's just simply asking how much do you have to pay at the end of the loan period. So what we have to do is we have to calculate our interest and then add it back to our principal to find out the total amount paid back. So a couple things. Time has to be in years. So does anyone happen to know how many days are in a year? Good. So we're not going to count leap year when we talk about this. So we take the 60 and you have to divide that by 365 to get it into a ratio of years. All right. Also, you can't multiply actual percents. Does anyone know how to turn a percent into a decimal? Good. You just go two places to the left, or you could divide by 100. Either way works for you. Works. So this ends up actually being 0.06. So those are the two steps you have to do, and then after that, you just plug it in. So my P is going to be my original loan, so that's my principal amount. So that's going to be 2,000 times, because that's what a letter next to a letter next to a letter all indicates multiplication. So now times my rate, which is going to be 0.06, times my time, which in this case is going to be 60 over 365. If you wanted to simplify this at this point, you could have and used a simpler fraction. It doesn't really matter. But you're just going to multiply this straight up. And so this is where a calculator would come in handy because there's a lot going on here. So I'm going to pull a regular old calculator here. I'm going to start off with the fraction first because that's the most complicated thing. I'm going to just say 60 divided by 365. And I get some long decimal. I'm not going to write that decimal down. I'm just going to hit the multiplication sign because what it does, it'll take that answer for me. So I don't got to worry about multiplying it again or like writing that number. So like after you did 60 divided by 365, you get this number. And if you just hit the times, it's taking that number. So you don't have to type it again. Right. And then I'm just going to type 0.06. And then I hit enter. It gives me the new number. Again, I'm not going to write that number down. I'm just going to hit times because again, it's going to copy that number for me. And now I'm going to put the 2000. So I can see that I had an interest of $19.73. So when you're dealing with money, you always want to go to the hundreds place, which is what I like to call the pennies. When it comes to rounding, you look at the third decimal place, which is the thousandths, and you ask yourself if it's 5 or more, the number beforehand goes up 1. If it is 4 or less, the number would stay the same. So since this is a 6, this 2 is going to become a 3. So my interest here is 19.73. Now we do all that work. We think we're done, but the question was asking how much do you have to pay at the end of the loan period? So this is our interest, and then we're paying this back in 60 days. So we have to tack it on to the loan we're paying back. So we just got to add this to 2,000. And what would you get? There you go. Correct. Yeah, I did that first because what I like to do is I like to deal with the hardest things first. Fractions are the hardest, so I'll do that first. Then I'll take that result, I'll multiply any decimals, and then I'll multiply whole numbers. So that's the way I like to approach these problems. Just so because you can go this direction, but when you end up trying to type the 60 over 365 after you've already multiplied this, what sometimes happens, it multiplies the 60 and then divides the 365. And you want this to become a number first so that you can multiply it out. It's not a big deal right now, but when we have some adding going on, it will become a big deal. Right, so we okay there? Absolutely. 21st century. Love it. All right. So that's the first type of problem you're going to see on your homework. The next one you're going to see is what they call the temperature formula. And again, what I've noticed is they give you the formula every time. And on some of them, they actually told you what all of the letters represented too. You just had to make sure you plugged it in. So the temperature here, they give you the Celsius formula. So Celsius is equal to 5 ninths times Fahrenheit minus 32. Okay. So again, they typically give you the formula. C is going to be for Celsius. Hopefully I spelled that right. There it is. And F is Fahrenheit. Okay. And so they give you the formula, and this will be example 2. And they'll say, given this, find F if C is equal to 50 degrees. Okay. So I'm going to take what I know, which is this 50 here, and I'm going to plug it into this formula. So I now get 50 equals 5 ninths times F, because that's what I'm trying to find. That's my variable, minus 32. And what we just did is we just developed an equation to solve. So this is what we did in the first 3 sections, but we were given the equation. Now we had to produce it first. So as a review from Monday, how do I get rid of a fraction? Okay, times what on both? The reciprocal, the flip first. So good. What you do to one side, you have to do to the other. But to get rid of it originally, I have to multiply by its reciprocal, which basically just means flip the fraction. So I'm going to do the same thing to the other side. So now, do I need these parentheses anymore? No. Alternatively, what we also saw too with the parentheses is we could have distribute this as well. Would that have been easier? I mean, it's a way to do it, but in this case, I just want to get rid of the fraction to begin with. But we could have definitely took the 5/9, multiplied it to the f, multiplied it to 32, and gone from there as well.
Personally, no.
Yeah, hate fractions. Oh, I get it. So that will be my start there, is just to get rid of. Yeah, no, I get it. I get it. All right, so then from here, we just got to figure this out. So I'm going to grab a calculator. And again, I'm going to start with that fraction first. So I'll do 9 divided by 5. I get my decimal of 1.8, and then I'm just going to times it by 50. So times, again, when I hit that times button, it copies that 1.8 for me. And I put in that 50. I get 90. What do I do now? Well, 90 equals f minus 32.
So I would, if we're doing, is it?
So we're still, we're still solving for f. Perfect. I still got to get rid of this minus 32, so I'm going to add 32 over. And now we just got to figure out what 90 plus 32 is. Perfect. So basically, if it's 50 degrees Celsius, it's 122 degrees Fahrenheit. So this is probably Texas in August. So again, on these type of word problems, they give you the formula. You just got to plug in what you know, use our equation skills that we learned in 9.1 through 3, and solve it out. So we okay with this one? All right. So they got a lot of them for you. The next one is what they call, what is that? Well, that's not one of their basic ones. All right, so some of them won't be like your generic ones, but they'll always give you the equation for those. So this one says, use the formula. So they give it to you. F equals K times A times V squared. This looks like a physics problem. I'm going to go with like force, constant, altitude maybe. I don't know. But that's not the point. It's going to then tell you what everything is. So use this form. Oh, go away. Okay. So then it says, use this to find the force, which is the F, exerted on a plane's wing during takeoff if the area, which is your A, so it told me that F was force, and it told me A was area of the wing, and then it told me, hey, area is 100 feet squared. Then it told me the K is just 5 force. It didn't even tell me what K was. And that the V is equal to 90 miles per hour. So that's I'm thinking velocity. Kind of going back to my physics. That's last time I took that course was in high school. So, but again, it gave you a formula in the problem, but then it told you what everything was. All right, so you don't have to worry about memorizing formulas. The key to these type of problems is given the formula, plug in what you know, solve for what you don't. In this case, it's super nice because I'm asked to look for F, which is already solved for. So when I plug it all in, I'm just really just doing the math. So here we go. So F would equal my K, which is 5 force, times my area, which was 100, the V squared. So my V was 90, so that would be 90 squared. Now, I don't think we've done a problem like this before, but y'all know this right here, PEMDAS? I think they've now called it GEMDAS. Go ahead.
You said area was 100 squared.
Oh, sorry, 100 feet squared is the units.
Oh, okay.
Yeah. So when you're you're good. So when you're dealing with measurements, perimeter is one dimensional because it's like the fence. It's just sides. area is two-dimensional. So like the space here, this would be a two-dimensional space. So I'll take the side lengths and multiply them together. That's why the unit becomes squared.
Okay.
And then volume is three-dimensional because it's length, width, and height. So that's why the units are going to be like cubics or feet cubic or whatever it is. So this right here just indicates that it is a two-dimensional figure. And that's what area is. Area is like the floor. Perimeter is like a straight line. Does that make sense? Yeah, so it has nothing to do with the actual to the number. It just tells you area is a two-dimensional figure in feet in this case. No, I got you. No, you're good. That's a great question. Because I have some students that try to put the feet square into the problem. I'm like, no, that's just the units. That's not part of the number. Yeah, go ahead. Good. Well, that's important. I want to know what this squared right here would be called. That starts with an E. Exponents. Yeah, so I have to do this exponent of 90 squared before I can do this multiplication. So that's why I want to bring that up. So I'm going to rewrite 5/4 times 100. And I need to go figure out what 90 squared is. So I'm going to, oh, look, it's happens to already be 90, but I'm going to retype it. I'm going to do 90. And then you see this little button, X squared. You can hit this one or do 90 times 90. Either way works. That's what squared means. So this right here just means 90 times 90 if you wanted to try to do it a different way. So I'm going to hit that square button, and then there it is right there. So 8,100. But now that I've done the square, multiplication is the next thing, and I can just start wherever I want. So I'm going to start with that 5/4. It's a fraction. Gives me 1.25. Then I'll hit times. So it allows me to, it copies that number for me. I'll do 100 times the 8,100. And again, every time it's just copying that number for me. Go ahead. So I did 5 divided by 4. Yeah, sorry. Yeah, a fraction means division. We no longer see this little sign here anymore. It's now going to be a fraction bar. So I did 5 divided by 4 first, got 1.25. You're good. Multiplied by 100, got 125, and then took that number, and I'm about to multiply it by 8,100. And when I did, I got this really big number. Sorry, I can't keep it up at the same time. I'll let y'all write it down. But that would be the force. So 1, 0, 12, 500. There you go. Okay, yes? Yes, if you hit, you see a control button, CTRL. It's been a while since I've seen the 84. Oh, so used to those Inspires now. I'm telling you, I learned more from the students when I first got introduced to it.
It was our fall program. It was Wacky Wednesday, so I was so wacky I dressed a different day.
Oh yeah, today we're on Red Ribbon Week.
Just a little bit. And then we got an email stating that we can't take our bicycles next year. I said that's not. They said it's a district thing. That I said, well, how in the world Super Creek is that haunted out?
So I'm thinking maybe they don't do it, but you would just do 5 divided by 4, and I'll make that fraction there for you. And then you can hit enter, and then take that and multiply it by your 100, and then take that and multiply it to your.
I don't know. It's not my favorite. I left the teachers in charge of it.
That was kind of more
yeah.
what we had, and it was kind of.
Yeah, I guess this one doesn't do it. I thought there was a book or something, but I don't see it. That's all right, because that's still a fraction right there for you. Okay. And then what you could do if you want to type it all at once, you could do parentheses 5 divided by 4 as well. And it'll do that math first
That's what I
before
did.
it did 100 and 80, 100. So if you wanted to type it all at the same time,
That's
there
what
you
I was
go.
asking, 'cause I seen you doing something. like
Yeah,
that
so
the other
if you,
day.
yeah, if we don't use the parentheses, what will happen is this is where it will do, well, it doesn't matter in this case because it's all multiplication, but if I had some addition there, they'll try to multiply these numbers before it divided it, and then that's gonna skew your data. So in this case, you just put it in parentheses to help it. And so the calculator will do, it'll do the fraction first and then the rest. No problem. Okay, there you go. So any questions on that? So again, it gives you the formula and then it tells you what each letter represents and then tells you some values and you just got to plug it in. That's pretty much how the rest of these questions go. I say that there are some that it does, just like in PEMDAS, it expects you to remember that. This next one's kind of the same concept. So this one says there's two angles of a triangle. So two angles. Of a triangle. And they measure 65 degrees and 85 degrees. And it wants to know what is the third measure. So this, you said was geometry in y'all's lab, would be a geometry question. And it expects you to know this coming into an algebra course. What does a triangle, all three angles, add up to? Anybody know? 180. So they are expecting you to remember that angle A plus B plus C will equal 180. So this is for a triangle. So like, here's how I try to remember it. Here's I don't know, we'll call it a rectangle. Most students will remember that this is 90, 90, 90, 90, which is 360. So they'll remember that one. Well, a triangle is just half of a rectangle. So therefore, a triangle must be 180. So that's how I have some students remember. They'll remember what a rectangle is, and they'll struggle with a triangle. So if you just half the 360, you're back to a triangle. So with that said, to solve this, what I have to do is do 65 plus 85, and then subtract that from 180. So this is basically what your formula is right here. We're going to combine like terms first. So this problem becomes hard if we don't remember that fact, because it doesn't tell you that fact. I'm gonna go 65 plus 85. I get 150. And then to solve this equation, sorry, I need to write it bigger. 150. I know I like to say it gets better, but 12 years and it's still the same. Some kids were like, well, slow down. I was like, well, my brain won't let me like slow it down. Like it's, yeah, I'm thinking too fast. Like, cause a lot of times, and y'all catch me on this too, if I haven't already done it. As I'm asking you the questions, I'm asking it with the answer. So like, if I say like, what's 2 plus 2, I'll accidentally be like, all right, it's 2 plus 4. Like I've already like moved on. I'm like, no. But then I'll just subtract. But you don't have to write it like this because you could just add and subtract. But I'm just showing you mathematically why we're doing this. And then 180 minus 150 would be 30. So that would be your missing degree. Ooh, degrees, yep. All right. So again, that question gets hard due to the fact that it expects you to memorize that or know that. All right, so another type like number 3. They'll give you a question that says something along these lines. Given P equals IV. We don't know what that is yet, but then it's going to say solve for I. Oh, okay. This is another step. In terms of P and V. So the first 4 questions there, give you a formula, plug in what you know, solve for what you don't know. This is what I like to call literal equations. You start with an equation, and then your answer is an equation. So in these things, they'll always give you a formula, some formula, and then they'll ask you to solve for some letter. Whatever that letter is, you can kind of ignore the rest because that's the only things you have. But whatever that letter is, I tell students to circle it. That's what we're trying to get by itself. So we have to ask ourselves, this is no numbers, so I'm going to end up with an equation again. What is the V doing to the I? What operation? It's multiplying. So what is the opposite of multiplying? Division. So typically we would divide by a number, but we don't have numbers, but the math doesn't change. It just looks different. I have to divide by V. But what I do on one side, have to do on the other side. Now, beforehand, I would figure out what these numbers were. I just don't have any numbers. So instead of simplifying it, that is your answer. So in literal equations, you're given an equation, you're asked to solve for a letter, and your answer is an equation. Let's do another one. What makes this hard is students want to come up with a number. They want to go, oh, the answer must be 7 or 5 or something. We'll throw a number. I'm like, where are you even getting numbers from? So it's going to be given as an equation. All right, on number 6, same concept. We're given P equals I over RT. And I'm sure all these formulas are some important formula in a science class or something, but you don't have to know that. Like you're just solving them. I don't know what none of these are. Yeah, I'm sure there's money or something, rate, time. Yeah, but
more stuff to it.
Yeah. Yeah, but you don't have to know what it represents. You just have to be able to solve for it. So that's what we have to do. Your science courses will teach you, oh, this teaches us gravity or whatever. I don't know. But all right, so you're given this formula and you're asked to solve for T. All right. So what I'm going to do to help myself out, I'm going to circle that T and try to figure out how I can solve it. Now, I don't think we've done a problem like this with numbers, but if the variable you're solving for is on the bottom of the fraction, I need it to come to the top of the fraction. So what that means is if it's on the bottom of a fraction, it's technically being divided, right? So I need to multiply because that's the opposite. So that's what I'm going to do right here. I'm going to multiply by T on both sides. And the purpose of this is to be able to solve for the letter. It cannot be on the bottom of a fraction. So what happens with these T's is they will cancel. Because if you multiply and divide by the exact same thing, you're just canceling it out. So now I got TP equals I over R. All right. So now what do I do to solve for P? IR is already by itself. I'm trying to get the T by itself. Good. I got to get rid of that P. And 2 letters mean multiplication. So I need to divide by P. Okay. So it looks like this. It looks like I divided by R divided by P, which looks almost ridiculous, right? When you're double dividing, the 2 denominators here go together. So it ends up looking like this. I over RP. Mathematically, this is why. You ever heard the term keep it, change it, flip it? When KCF, when dividing fractions, I can technically put this over 1. And what I'll do is I'll keep the first fraction, which is I over R. I'll change this division bar into a multiplication sign. And I'll flip P over 1 to become 1 over P. So, yeah, so this is like a fraction divided by a fraction. And the rule to this is keep, change, flip, or KCF, KFC, however you want to look at it. And so I keep the first fraction as is, change this to multiplication. So I changed it to multiplication. And then I flipped this fraction. So it was originally P over 1. Now it's 1 over P. And then we talked about this Monday, multiplying fractions, we just multiply straight across. So I times 1 is I, and then R times P is RP. So that's why we were able to get to this point right here. So my rule of thumb, if I'm dividing two things, double denominators here, just put them together. It's going to work out like that every single time. If you do forget, just remember KCF and you could work it back down to the correct answer as well. Good with that? What part got you?
It's okay.
Okay. Okay. Literal equations, because we're trying to get a number, can be complicated. All right, so let's look at another one. Let's look at number 7. So given y equals 2/5 times x plus 3, we're going to solve for x. All right, this is kind of like what we saw earlier with the Fahrenheit question. So I'm going to circle my x. That's the guy I'm trying to solve for. So you tell me what you want to do first. Okay, I like it. We'll distribute. Get rid of those parentheses. So 2/5 times x, sorry, 2/5 times x would be 2/5 x. I can't actually multiply numbers and letters, so we just round them next to each other. 2/5 times 3 would be okay. I think so. So 2 divided by 5, there's my fraction, times 3, 1.2. If you kept it as fraction form, I think it's 6/5. So I'm good there too. And the way you can get, oh, come on. Go away. Yeah, that's what I was going to. So yeah, so when I do the 2/5 times 3 concept right here, I can put a whole number over 1, and that goes straight across, and it's 6/5. So I'm good either way. 6/5, 1.2, decimals, nor fractions scare me. So I'm good either way. Now, what would I do now to get x by itself? Good. Gotta get rid of that addition subtraction. So how do I move that 1.2? Good. So I want to minus 1.2. Can't combine these, so I'm just going to write it out as y minus 1.2. Reciprocal 5/2. So I'm going to multiply this by 5/2. Right? So from that, I have to multiply this entire thing by 5/2. But I saw on your homework, once you got to this point right here, you can leave it like this. You don't have to actually worry about distributing it back out because you did the job and you got x by itself. So you can leave it as 5/2 y minus 1.2. Now, if you want it to distribute it, it's correct as well. So if you wanted to keep it going, but once you got the x by itself, I was playing with it because I can play as a student. And so I typed that answer in to see if it accepted, and it did. So yeah, so the goal there, I think, is x by itself. And once I did, it accepted the answer. All right, so we're good there. So the rules haven't changed from Monday. It's just we're not getting a number anymore. We're just getting more and more different equations. All right. All right, let's look at another one. All right, so now we're given 16y plus 25z equals 400. In the first part, you're asked to solve for y. So what would I do first? Circle my y. Where am I going to move first? Good. I gotta always get rid of the addition and subtraction of my equation. So I'm going to get rid of the plus 25, which is subtract 25z. Do watch out. Oh, that's an X. Do watch out here, though. You can't combine like terms. So I cannot subtract 25 from 400. So instead, it becomes 400 minus 25z. Okay. Perfect. 16 times y. So the opposite of that's divide by 16. And again, if you just divide it all by 16, you can leave it like that. You do not actually have to do 400 divided by 16, 25 divided by 16. This right here would be your answer. Yeah. Yeah. So I'll kind of review it one more time. No, I don't mind, because you might not be the only one with questions. I start out by circling what I'm looking for, which in this case was my y. And just like my rules in 9.1 through 9.3, I wanted to get rid of any addition and subtraction that's being done to the thing I'm looking for. So I see that I'm adding a 25z. So the opposite of adding is subtracting. And so I subtract it on both sides, because what I do to one side, I have to do to the other. The difference that this produces that 9.1 through 9.3 didn't is in 9.1 through 3, I was able to actually subtract. I would do 400 minus 25, get a number, and then move on to the next step. But in 9.4, you're given an equation because I can't actually combine these. So instead, I just write it as I see it. So 400 minus 25z. Then a number next to a letter indicates multiplication. So the opposite of that is division. Again, in 9.1 through 9.3, I would be able to divide this number by 16 and get another number. But I can't because there's too many letters in the equation. 9.1 through 3, we only had one letter. Well, sometimes it'll be multiple, but we combine like terms and get to become one letter. I can't combine a y and a z. They're just not the same. So when I divide it by the 16, that's all I can do. I can't actually physically divide it by 16 because of that letter. And so basically what you're doing is when you produce the equation, you're technically like writing the steps that you did to solve. Like you can see, oh, I would have subtracted and then I would have divided, and that's how I would solve for y if there wasn't a z, in a sense. It's like writing out your steps as the answer.
So question,
Go ahead.
you can never, if you have two different letters, you can never really.
Correct. The only thing, well, for right now, you can't solve it. Yeah. The only way to solve for two letters is you would need two equations. And I don't remember if we get into that in this class or if that's a college algebra course. Hold on. Yeah, no, yeah, that's the college algebra. Yeah, so we won't see that in this course at all. But in college algebra, we do teach you, all right, here's two variables, but here's two equations, and then we can solve. But here, yeah, if it's got more than one variable that's not the same, you know you're producing another equation because that's all you can do. I teach that one online. No one signed up for the face-to-face here. I do if people will make the class, I'm totally good with it. But this is my perfect. Mhm. I will recommend if they give you option, do that in a 16-week course because it's a lot for them in 16 weeks. If we put that in an 8 week, that's going to be brutal. Like I'm worried about this course because there's just so much that we have to learn. I've always recommended if you're ever going to take a course that's less than 16 weeks, take it on a course that you're already good at. So like if you're good at English, 8 weeks ain't going to be an issue. But if you struggle like in math, in 8 week, we're already going pretty fast in college to begin with, and now you're about to double time that. So it can be taxing. But I'll slow it down as much as I can for you. There's certain things I have to teach throughout the week. So, oh yeah, no, yeah. Perfect. I was hoping that sticks going into the test because that's usually what happens. Like, oh, I get it, and then the test comes going, no, I don't remember. So yeah, so all right, yeah. Hmm. I got you. Yeah, it throws it off. So I will say, anytime you have a fraction that's like being multiplied that you're trying to get rid of, that's when you're gonna want to. So y'all, all right, here it is. You want to multiply by the reciprocal. But if you're just trying to multiply it in itself to do the math, you just leave it as is. So it's all so anytime you're trying to move it to the other side of the equation, we have to do it on the same side. That's when it's going to be a reciprocal. If you're just doing math, you just keep it the same. So you can kind of look at it that way. Anytime I have to put it on the other side, that's when it's going to be flipped. Mm-hmm. All right, so let's do one more and then we'll call 9.4 done. Again, I only do these examples because this is what you'll see on your homework, and I want to make sure I give you one, the book gives you one, and then, of course, Hawks Learning itself will give you plenty of examples as well to go through. I just want to make sure you'll have everything at your disposal. So this is 4x plus 8y plus 12z equals 16. And we're going to solve for x. So I'm going to start off by circling what I'm trying to get by itself. So what do y'all want to do first? Okay, perfect. I see some addition, so I'm going to get rid of that first. So I'll bring down my 4x plus 12z. I can't combine these, so I write it out as 16 minus 8y. I will say if you make a mistake, that's where it's going to be made. You're going to try to combine like terms where it can't be done. What do you want? Good. My opposite of adding here is still subtracting, so I'm going to subtract 12z. Again, and I can't combine any of these, so I'm just going to rewrite it. So 16 minus 8y minus 12z. Ooh, that's a 4. But I totally get it because that does look like a 9.
Sorry.
That's a 4. Yeah. Oh, and that is number 9, but that's totally a 4. That's on me. So yeah, so then I'll divide by 4. And I don't have to worry about dividing all of it but individually. I can just right like that. Yep. No, that'd be your teacher's fault there. There you go. And again, there's no simplifying. It's a literal equation. You can look at it. There's more than one letter that's not the same, so I wasn't going to get an answer anyways. Not a number answer. Now, the benefits of doing this is now if I told you what y and z is, I can just immediately plug it in and solve it. and just do my PEMDAS versus having to plug it in and then still solve because X wasn't by itself. That's the point of why we do literal equations, to technically make it easier if you knew the other stuff eventually. So, questions on that? All right, so we're going to skip 9.5, which is more application problems. So no more word problems. It will show up in algebra. Oh, that's the word problems they took away. Oh, I was thinking we got more. Okay, gotcha. So they got rid of your consecutive ones, but they kept the famous distance equals rate times time one. All right. So let's get right into that.